what happens if we have a circuit with just a capacitor and an inductor? First of all, there's no source, so where's the energy coming from? Well, this is due to the energy stored in the capacitor and inductor. So we have two initial conditions: the initial voltage across the capacitor and the initial current in the inductor. Here, the two components are both in series and in parallel. So they have the same current, except the labeled currents flow the opposite way, and so IC is negative IL. Let's express both of these in terms of this common voltage, V. For a capacitor, the displacement current is given by C times the derivative of voltage. For an inductor, we can express the current as the integral of the voltage divided by the inductance. So we have an integral differential equation here, and so we can simplify this by differentiating both sides. Doing so, we'll have a second derivative on the left, and we'll undo the integral on the right, like this. Let's now divide by C, and with this we have a second-order differential equation with two initial conditions. It can be easily shown that the solution to this is a sinusoid, where A and B are determined from the two initial conditions. And even if you don't have a lot of expertise with differential equations, it makes sense that a sinusoid satisfies this differential equation, because if you were to think of a function whose second derivative is a multiple of the function itself, then a sinusoid is your best bet. So, this common voltage V in the circuit is a sinusoid, and we can show that the inductor and capacitor currents are also sinusoids. Okay, so how is this significant? Well, we can find the energy stored in the capacitor and inductor as functions of time. For the capacitor, this is half C times the square of the voltage. For the inductor, this is half L times the square of the current. These will also vary sinusoidally, and so we can see that the energy in the circuit is passed back and forth between the two energy storage elements. The energy flows back and forth from the magnetic field around the inductor to the electric field in the capacitor. Practically, though, we cannot have a circuit with absolutely no resistance, because a more practical model for a capacitor and an inductor would involve a resistive component, and so we cannot have a perfectly sinusoidal response. There will always be some damping, some loss in the amplitude. But now you know